Hi, welcome to your next programming challenge entitled Case Insensitive Comparison. You are to write a function that validates whether two strings are identical. Make it case insensitive. That's sort of the catch. Refer to the examples below. Notice that the first one returns true because both say hello, the difference only being that in the second parameter we have some of the letters capitalized. Since this is case insensitive, we don't care and we say that's a match. The second one, make sure you would note it's false because there's this leading E here, so they are slightly different. If you look at it quickly, they may look the same, but they're not. Venom and venom would be true, and these are two obviously different words, mask and masking, so you get false. I think that's clear enough. On to the coding. As usual, pause, think about this, and do your own implementation. If you got stuck, your first hint will be that there is a built-in method for the string class that can make this a very simple problem, a one-liner. Feel free to pause again and try with that knowledge. Okay, so hopefully you didn't get stuck thinking you had to do a lot of work here. Maybe you would have started by doing something like if string 1.length is not equal to s2.length, right? This would be a nice quick check to sort of rule out any chance of them matching. If they have different sizes, they're clearly not the same word regardless of capitalization. So you could just say return false automatically here. Then assuming that you get beyond this to this point in the code, you already know that the two strings are the same length. So then maybe you made a for loop. You could pick either string size since they're both the same. And then you got this ugly scenario where you kind of got to go character by character, but it's not good enough to compare each letter to each other's. So you can't just simply go if s1 I equals s2 at index I, because this wouldn't cover the case insensitivity, right? This would just make sure that they match exactly. Remember that the letters are just represented by numbers, each character, and so it doesn't, there's no special meaning between lowercase and uppercase in terms of the character that the computer prints for an associated value. So maybe you looked up ASCII tables to see how these letters are represented. You notice the letters in this column, capital, lowercase, and maybe you tried to note that there's a constant offset between a capital letter and its lowercase equivalent. You know, there's what, 32 difference between 65 and 97. I'm looking in the decimal column because that's the way my brain works. If you know hex and octal, you can refer to those equivalents. But yeah, so this can get really ugly, right? And then you don't know if the letter in question, if it was the lowercase one where you have to add 32 or it's upper, and or you know, vice versa, whatever, you're looking both ways to see. This gets really ugly, right? And that's not very fun. So that's clever if you try to do it that way, not realizing that there's built-in functionality for you. But we can do a lot better than this, and let's do that now. So we are dealing with strings, so if you did refer to the Microsoft Docs, string would have been a good place to start, and the key was finding this compare method. Again, we got overload city here in this column, lots of weird looking things, string comparison, culture info, so it gets a little scary there. Don't worry about it, we'll find a simple one. The other thing to note is that this uses the system namespace, so we're probably going to have to add a using statement for that. Here, string boolean, this looks good. here we go. Compares two string objects, ignoring or honoring their case, which is what this Boolean would be. So let's click on that one to go there. Yeah, and you can see it's ignore case. And the other thing to note is that this returns an integer, so it's not going to say true or false whether the strings match. It's actually going to give you an integer value that's kind of is useful if you were actually sorting a bunch of strings. We're not here, we're just looking for equality, so we want it to be equal to 0. That's the case where it matches. If string A precedes string B alphabetically, you'll get a less than 0 value, and you'll get a value greater than 0 if it's after in sorting order. So we just care that it equals to 0. If it's not equal to 0, it's not a match. But this little Boolean flag here gives a really nice way for us to just say true here. We do want it to ignore case. So let's try it that way. Remember, we got to bring in that code. We don't have it right here in our window, so we got to pull it in from the system namespace. Then we can do return, string compare, that was the method, and we'll give it our two strings, S1, S2. Do we want to ignore case? We're going to say true because we do want to ignore case. If we didn't, we would provide a false argument here. And remember, this returns an integer. We need a bool. So let's go that the compare result is the value of 0. That would mean they match. And I think this is good enough, but we'll find out. And there we go. Look at that. Isn't that so much nicer? So look at all the time savings. Had we tried to write a bunch of logic to compare character values for upper and lower case, we would have had a whole bunch of code to write there. And so you can really see the power of these, bringing these namespaces in and leveraging this work that other people have already done. You can imagine how many people work with strings, and it would be just such a waste of time if everybody had to implement their own version of this stuff all of the time. This way it's implemented once, it's battle tested, thousands of people are using it all the time, so you can be pretty sure that it does what you expect it to do, which is nice. So yeah, there's the nice one-liner. Hopefully this video is useful. Leave questions and comments below. Thank you.